How are things going with your design team?
Yeah, they're going really well. We finished the last of our suspension parts, and we have some really cool ones this year too, made of carbon fiber, but not too many since we're concerned about the environment and they come from a non-renewable resource. Carbon fiber is a lightweight, high-strength material made of woven strands of crystalline carbon filament. When combined with resin, it becomes stiff, and it can be formed into sheets of stock material, or it can be molded into complex curvatures. We as students are most intimately familiar with its uses on our design team projects, but it has further uses in jet engines, turbines, and propellers. Currently, the majority of carbon fiber on the market is made from polyacrylonitrile, which is a non-renewable petroleum-based polymer.
Have you heard you can now make carbon fiber from renewable materials?
Oh, really?
Yes, so now they have been starting research and developing on carbon fiber made from lignin. So the byproduct of pulping of wood chips can be made into carbon fiber.
No way! You're telling me this tree can be made into a high-strength car part? Yes, that's exactly what he's saying, and here's how. The process begins with the tree. The tree is cut down and sent to a sawmill for processing. The residual wood from lumber production is shredded and made into wood chips. Wood chips can also be sourced from wood grown in a plantation with the sole purpose of being made into pulp. The wood chips are then sent to a pulp mill where they undergo chemical pulping. This is important as only the chemical pulping process is viable for eventual carbon fiber production. We will talk about this a bit later. Once the wood chips arrive at the pulping plant, they are processed into pulp through the use of craft cooking liquors, also called white liquor. Through the use of increased temperature and pressure, the white liquor penetrates deep into the wood matrix where the most important step happens. A special polymer found in the cell walls of the wood fibers is dissolved. This polymer is called lignin. Lignin is the star of the show here. It is what is used as the precursor to carbon fiber production, a renewable alternative to polyacrylonitrile. Lignin is an organic polymer found in tracheids and xylem vessels that is responsible for adding rigidity and strength to the cell walls, as well as binding them together. More specifically, lignin is found in the S2 layer of the secondary wall, as well as the middle lamella layer, with the majority of lignin being contained in the former. Once the white liquor penetrates into the wood fibers and the reaction has been given ample time to take place, the resultant pulp is moved along for further delignification and bleaching. The waste products, combined with the cooking liquor, forms a solution known as black liquor. Remember earlier when I said that it was important for eventual carbon fiber production that chemical pulping was used? Black liquor is the reason. Lignin used to make carbon fiber is most commonly sourced from black liquor. Mechanical pulping does not yield such a byproduct, since the lignin is removed through physical means instead of being dissolved. This black liquor can also be sourced from a biorefinery as a byproduct of ethanol production. This black liquor solution can be regenerated back to white liquor through various chemical processes. The one that is important to this topic is lignin precipitation. This process involves a series of complex chemical reactions, but an important detail is that the solution must be acidified and heated to increase the overall yield of lignin that can be recovered. Once the lignin is precipitated from the black liquor solution, it is washed in both sulfuric acid and then water. It is then dried in a vacuum oven where the excess moisture and sulfur is removed. The lignin, once dried, can be used for many things, including combustion heating, production of adhesives, or even the creation of surfactants. But we will discuss its use in creating carbon nanofibers. The dried lignin, usually in the form of pellets, is melted and then made into carbon nanofibers through a process called electrospinning. Electrospinning is a process in which a liquid droplet is electrified and then elongated to form an ultra-thin fiber. The fiber is then collected on a grounded collector. Electrospinning can be summarized into four main processes: the charging of a liquid droplet to form a jet, elongation of the jet, thinning of the jet using electric fields, and collection of the nanofibers on a grounded collector. Once the fibers are produced, they are woven into sheets and are ready to be used.
In the production of carbon fibers, the manufacturing process plays a large role in determining the material properties. One material property of carbon fiber that is most important for their applications is the tensile strength. Looking into their tensile strength, traditional carbon fibers range from 3 gigapascals to 7 gigapascals. On the other hand, for lignin-based carbon fibers, their tensile strength only goes up to 0.55 gigapascals. Because of the weaker tensile strength, lignin-based carbon fibers are usually combined with other polymers such as PP, PET, PAN, etc. The combination between the lignin and these polymers create carbon fiber with higher tensile strength, usually up to 1 gigapascal. However, this is still not enough to replace traditional carbon fiber, especially in applications that requires high tensile strength. Now, let us compare the two from a different standpoint. When it comes to the environmental effects of lignin-based carbon fibers, studies show that these bio-based carbon fibers reduce carbon emission compared to the traditional, non-environmental friendly carbon fibers, compared to those from the conventional carbon fibers. Looking at the life cycle assessment of carbon fibers itself, Johnson et al. Found that the climate impact from producing 1 kilogram of lignin-based carbon fiber produces about 1.5 kilograms of carbon dioxide equivalent. On the other hand, 1 kilogram of fossil-based carbon fiber resulted in almost 39 kilograms of carbon dioxide equivalent. This is a difference of 96% in the resulting carbon emissions. So, from an environmental point of view, lignin-based carbon fibers are in a huge advantage.
The environmental benefits are pretty clear to see, but what kind of impact would switching to lignin-based carbon fiber have economically? There are still several hurdles preventing lignin-based carbon fiber from becoming widespread commercially. One of the largest ones is consistency. Not all lignin is the same. Properties such as thermoplasticity and solubility are dependent on the type of tree that the lignin originated from. And since most feedstocks originate from a blend of different tree species and residual wood sources, this is very hard to control. On a related note, the pulping process or biorefining process can also introduce microscopic impurities that can affect the quality of the final precursor fibers. This results in a final product that is not structurally homogeneous. Processing routes to create lignin-based carbon fiber are also in need of further development. Most known processing routes are optimized for a specific type of lignin. This makes it difficult to scale up production since not all lignin is compatible with each manufacturing process. This can lead to further expenses during post-processing of the lignin carbon fibers. Lastly, a market for lignin-based carbon fiber needs to be identified and targeted. As it stands right now, lignin-based carbon fiber isn't mechanically suitable for uses in the aerospace or automotive industries. Production plants are still limited to labs or pilot facilities, so getting a large-scale cost estimate is very difficult. Pan-based carbon fiber is widespread among numerous industries, and its processing routes have been studied extensively. Even so, it still has high production costs and a very unfavorable carbon footprint.
Wow, I had no idea carbon fiber can be made from trees like that. But it still sounds like there's a ways to go before it can fully replace traditional carbon fiber, though.
That's true. Despite all the challenges, I do believe that bio-based carbon fiber can be achieved in the near future.
Yeah, especially now more than ever, we need to be looking to reduce our carbon emissions wherever we can. I, for one, can't wait for the day where parts of my car can be made from a tree.
Me too. Arjun, me too.